In this video, we're going to be looking at oxidation states, what they are, and how you determine their oxidation state in a compound. So you have this notes sheet, and the question is, what is an oxidation state? And an oxidation state is a number that shows the total number of electrons I'm going to abbreviate electrons with an E minus just because I don't have a lot of space. The total number of electrons that have been removed and if they have been removed, they have a positive oxidation state. And we all know that electrons can be removed or they can be added. So they can be added, which would give them a negative oxidation state. So it's a number that shows the total number of electrons that have been removed or added to get to its present state. And you'll actually see this is very similar to charge, which we've talked about before. Whenever you have a pure element, it's very easy to determine its oxidation state because it is 0. Things get a little bit more complicated when you have compounds. There's a list of rules on your note sheet. If you take a minute to look that over, keep this paper handy because we're going to use it to do some practice problems. So after this, you're going to look at the paper that has the charts, and we're going to work through a couple of those together. Alright, so these are the examples we're going to look at. We've got zinc iodide. By this time, you should have figured out that the formula is ZnI2. And I gave you, on some of these, the rules don't help you assign all of the numbers, so I have a few of them that are given. So on all of these examples, if you just follow the chart will lead you through how to do this. You write zinc, and then we would write I, and then this one would be blank because we only have 2 elements. You write their subscripts, which would be 1 and 2. And these sort of work like a math box. You multiply going down, so this is plus 2. We don't know the oxidation state of iodide yet, so we still have to figure that out. But in a compound, the total oxidation state is 0. And so if we work across here, plus 2 would have to be balanced out by minus 2 to get us to 0. And then you work backwards from there, and you see that minus 1 is what would give you a minus 2 in this column. So it's multiplying going up and down, and it's adding going across. And on all of these examples, you're going to get to 0. I left this blank because there are some cases where it wouldn't be 0 if you're doing a polyatomic ion, but we're doing compounds, so it's always going to be 0. All right, we'll go ahead and take a look at number 2. We have copper, and you should have written this for your formula, CuSO4. And we're going to go ahead and break up sulfur and oxygen here. Even though when we balanced equations, I told you to keep that together, for this it would help to break them up. So you've got copper as plus 2, and then go ahead and list your subscripts, 1, 1, and 4. We know the total is going to be 0. You could go ahead and multiply this column, so you know that's plus 2. And then one of your rules on your the sheet that we just did together tells you that O is always minus 2. So we have 4 times minus 2 equals minus 8. And then you think, what would give this a total of 0? You'd have to put in plus 6 here. And you work backwards. There's only one S, so 1 times plus 6 equals 6. Well, that's that one. I'm going to let you do zinc sulfate on your own. It's very similar to copper sulfate. ZnSO4 is your formula. And the final example we're going to do together right now is potassium perchlorate. You should have KClO4 here. So you list your 3 elements, K, Cl, and O. You list your subscripts, 1, 1, and 4. O is always minus 2. Go ahead and fill that in. K is a group 1 metal, so it's going to be plus 1. Another one of your rules. Multiply the columns that you have. 1 times plus 1, 4 times minus 2. Your total has to add up to 0. And so if you sort of think about this math problem in your head, you need this column to be plus 7 to make all of these sums add up to 0. And with 1 chlorine, its oxidation state is plus 7. Alright, you can work on some of these other ones on your own, and we'll take a look at those together in class.